with the trigonometric identities, we already discussed all these. This is nothing new. So we can just go ahead and choose problems. They all come from page 526. I have the book in the background. And we can choose from many questions, or we can work on the handout. It's up to you. So yeah, let's see. We have something in the chat. Yeah, so a problem like that, we did it together. Last Monday. So plus 8, let's say cosine 30 degrees. So all you have to do is identify that this is 1 and this is 8, and cosine 30 degrees is the square root of 3/2. And you simplify, and the final answer is this. And you don't need to do anything else. So this was a similar problem with the one we did in class on the review. Is that okay? Eli, is this okay?
Yeah, that's good. Thank you.
Sure. Good. So now let's continue. Let me open the, let's go to the book. So that's not the book. Where is my book? Where is my book? Right here. Okay, so we're talking about trig identities. And again, so let me open, where do I have this? Where is my, okay, here it is. So, so here is the handout that we are looking at right now. So it's 6.4 trigonometric identities. And it's posted. All handouts are posted. So there is nothing to say here because we worked on these and worked on these and all these from the very beginning of chapter 6. Okay, so there is nothing to say. So the handout that I have right here in front of me as well, printed out, has these problems. Simplify each trig identity. I'm sorry, each trig expression. And then the next step is establish each identity. In other words, show that the left equals the right. And here we have, when we get to this part, we have 3 options. We start from the left and get to the right-hand side, or we start from the right-hand side and show that it's the left-hand side, or we have to simplify both sides and show that they simplify to the same thing. So again, we can start on the left and show that we obtain the right-hand side. We can start from the right and show that we obtain the left-hand side, or it happens that both sides are complicated, so we have to simplify this fully. We have to simplify the other side fully and show that they are the same. So let's start with, we don't have to choose these problems. We can choose other problems from the textbook. Where is my textbook? Right here. What would you prefer? Would you like to start with a handout or directly picking problems? Is anyone with me?
We probably, what was it? Start with the handout?
Okay, perfect. So in that case, so let's start with 14. In 14, we are asked to multiply those two. So we have sine theta over 1 plus cosine theta. They want us to multiply top and bottom by 1 minus cosine theta over 1 plus 1, of course, 1 minus cosine theta. This is 1. So multiplying by a fraction by 1, it will never make a difference. There is no change. As long as we multiply top and bottom by the same quantity, there is no change. And for some reason, okay, good. So when we do that, we just multiply 2 fractions. We write sine theta multiplied by 1 minus cosine theta. But can anyone multiply these two? Because we know a lot of special products. Can anyone multiply these two and tell us what we get? And this should be just in a blink. The answer should come to us in a blink. What is 1 plus cosine times 1 minus cosine? What does it equal to?
Sine theta.
Say it again.
I think I'm wrong.
That's okay. So first of all, let's multiply them. I know you're way ahead of me. That's awesome. So let's multiply them first. Can anyone multiply 1 plus cosine times 1 minus cosine and give us the answer? There is a special product for this. We shouldn't think. We should just scream the answer. Anyone? Anyone? Please.
I don't know if I'm wrong, but I think it's one minus cosine theta squared.
Of course, we have to say cosine squared of theta. Yes, it's a plus b times a minus b, which is a squared minus b squared. Awesome. Exactly. You don't have to use FOIL, right? This will be a waste of time. We need to know 1 plus or a plus b times a minus b is a squared minus b squared. Good. Very good. Now, what do we know? A very, very basic and important identity. What is 1 minus cosine squared? What can I replace this by?
You can replace it with sine squared.
Excellent.
Theta.
Yes, thank you very much. Sine squared theta. I have a sine theta at the top and 1 minus cosine theta. And of course, I will simplify. I'm simplifying factors. So I simplify the sine from the top with the sine from the bottom. So this is 1 minus cosine theta over sine theta. I want you to add to the list of identities that we already know. I would like you to add the following. It's a very important identity. You can say, why is it, if it's so important, why is it not on this list? It will come into play a little bit later, and you'll see how and when. But it's important to write it somewhere close to the list of formulas. What is it again? Sine theta over 1 plus cosine theta equals 1 minus cosine theta over sine theta. Of course, if you can also reverse these two, it will still be the same thing. But please add this to the list of identities. And remember that sine over 1 plus cosine, of course, of the same angle, is 1 minus cosine over sine. So this is a very important identity. Moving forward, you'll see it will come into play soon. Okay, I'm sharing my screen. So we multiply these two. So sine theta over 1 plus cosine theta times this is 1 minus cosine theta over sine theta. We just added it to the list of important identities. Okay, so now in this situation, we are adding two fractions. What is the least common denominator? So that's my page 2. So we have 1 minus cosine v plus 1 over 1 plus cosine v. Please have the courage to say something. It's okay if you're wrong. There's never enough room on my table. Okay.
Right, excuse me, Professor.
Yes.
I actually have a question on the last
Yes.
exercise that we just did.
Yes.
Why can't we just, I don't know if I'm wrong, but 1 minus cosine, can't there just be sine and then we can just simplify that?
So, you mean here?
Yes.
Excellent. So let's discuss this. Very good question. So we know that sine squared alpha plus cosine squared alpha equals 1. If we want to solve for sine, we move cosine to the other side. And we have to take the square root from both sides. And then sine alpha equals plus or minus the square root of 1 minus cosine squared alpha. Careful now. The square root of a minus b does not equal the square root of a minus the square root of b. So what I'm saying here is that this is carved in stone. No one can simplify this any further. So sine will never equal 1 minus cosine. Sine equals plus or minus the square root of 1 minus cosine squared, which can never be simplified. Does it make sense?
Yes, thank you.
It's the only way. So don't ever feel that the question was inappropriate or not interesting. Every question is interesting. Here's why. So let me switch the camera so you can see me. So every question you ask makes me a better professor. How come? Because when you ask a question and I didn't think of saying something, it makes me think and say, I should have said that. So that the student would have that understood better from the very beginning. So always ask anything that comes to mind and we clarify it in class. It's the best way. Okay? Do I get a thumbs up or agreed, disagreed? Is anybody with me? Okay. Okay, I got one. Thank you, Blake. Good. So, thank you, Eli. Thank you. Okay, so therefore, these are not the same. We cannot simplify them. It was a very good question. I should have mentioned all these again. So I think it really helped me. But is it clear now?
Yes, it's clear.
Excellent. Good. Moving on. Good. So now we are asked to add these two. We need to find the least common denominator. Can anyone help with the least common denominator? Can anyone help with the least common denominator, please? I know you know.
1 minus cosine and 1 plus cosine.
Excellent. So 1 minus cosine v times 1 plus cosine v, which means this one was multiplied by this. So we have to multiply the top, 1 plus cosine v. This was multiplied by this, so we have to multiply the top by 1 minus cosine v. And now I copy what we get at the top, 1 plus cosine v plus 1 minus cosine v. Of course, these two go away because one is plus, one is minus. The final simplified form at the top is this. When we multiply these two, can anyone quickly tell us what we get? Because we had the situation a minute ago.
One minus cosine v squared.
Very good. Cosine squared v. Okay, here's a very good point. Cosine v squared is one thing. Cosine squared applied to v is a different thing. This is the same with this. This requires us to square the argument first. So this is number one. And then number two, apply cosine to that number. So we have to say, in this case, we have to say cosine squared of v, because if we say cosine v squared, you have to simplify, you have to think in these terms in this situation, not squaring the argument and then applying cosine. So if you say this, then you have to say parentheses. So it's better or easier to say this, but it's okay. They're both okay. Good. So now what did we say? 1 minus cosine squared v. Cosine squared v, not 1 minus cosine, but 1 minus cosine squared v was equal to.
V.
You mean sine squared v, right? 1 minus cosine squared
Yeah.
v equals sine squared v, assuming that there is no radical. Good. Now, 2 over sine squared. I'm jumping over, follow the circle. So I'm going to write it one more time in here. 2 over sine squared v. What function is 1 over sine or 1 over sine squared?
ESC.
Yes, squared v. Very good. And this is the final simplified form. Excellent. So 1 over sine is cosecant. Because it's squared, I have to square it. So cosecant squared of v multiplied by 2 outside. 2 times cosecant squared v. Do we understand these problems? Do we have any questions? Okay, I'm going to share the screen again. Okay, so again, we are asked to multiply, factor, and simplify. Please choose or both.
Can we do both?
Yes, perfect. So number 3, page 3. Okay, so 18. In 18, we have tangent theta plus 1 times tangent theta plus 1. It should have been squared outside the parentheses, but that's okay. Minus secant squared theta over tangent theta. Perfect. Good. So can anyone multiply these two for us? Again, we should use the formula. It should take a blink. So, can anyone give us tangent theta plus 1 squared? Anyone, please? Anyone?
Tangent squared of theta
Yes, tangent square theta plus
plus 2 tangent theta plus 1.
plus 1. Excellent. Now, remember the 3 identities. You have to remember these. I'm going to just leave some room. So we have sine squared alpha plus cosine squared alpha equals 1. 1 plus tangent squared alpha equals secant squared alpha. And 1 plus cotangent squared alpha equals cosecant squared alpha. Where does this come from? Remember, we divide both sides here by sine squared, and we get this. We divide both sides here by cosine squared, and we get this. These two come from this one. But we have to be very careful and how do we use them and remember them, because they're extremely useful. Why? Because I'm going to ask you, what do we replace secant squared by? And you have to say 1 plus tangent squared. Why did I ever think of this? Because of what I see here. So the negative secant squared. This is positive secant squared, and I need negative secant squared. What do I replace negative secant squared by? Please help.
-1 minus tangent squared.
Excellent. Excellent. Minus tangent squared theta. Excellent. Look what happens. All I'm left with is 2 tangent theta over tangent theta. What does that equal to? Anyone?
Tangent of theta.
That's it. This is it. Perfect. Okay. Factor and simplify. Any questions before we continue? Let me